Okay, on this problem we have the integral from 1 to 2 of 6 times 1 plus ln x times x to the 6x dx. Okay, so the way we're going to approach this problem, we're first going to look at this term x to the 6x power, and I'm going to rewrite that over here. So I'll say x to the 6x. I'm going to say that is e to the ln of x to the 6x. Now, that's a special property of the natural logarithms and the natural exponential function, is that when you put them together, they cancel out. So we're kind of working that backwards there. And it gives us the ability to take this exponent 6x and move it down in front of the ln. So this becomes e to the 6x ln x. Okay, so what we're hoping here is that we have something of the form e to the u du. That is what we want to get towards. Okay, so let's see if we can get something of the form e to the u, which would mean that this right here, 6x ln x, is our u. So if u is equal to 6x ln x, then du is equal to, well, we need to use the product rule. Here's the first term and the second term. So the product rule will give us 6x times the derivative of ln x, which is 1 over x, plus derivative of this is 6 times ln x. Okay, and that is all dx. Okay, so let's clean that up a little. We get du is equal to, the x's cancel out, 6 plus 6 ln x dx. And it looks kind of familiar. It kind of looks like this right here if I factored out a 6. Okay, so let's do that. du is equal to 6 times 1 plus ln x dx. Okay, so that looks like it's going to work for us to cancel out that term when we do u substitution. So if I divide both sides by this to get dx by itself, I'll get du over 6 times 1 plus ln x equals dx. So I can do that substitution. And you notice when I do that substitution for dx, it's going to make this term cancel. Okay, so I've got this x to the 6x is this, okay, and I'm going to say that that's actually e to the u. Now that I know it's going to work out, I'm going ahead and put that. So I have e to the u is all this stuff, and my dx is du over this. So we have the integral of 6 times 1 plus ln x times e to the u, and then times, what is our dx? Well, our dx is this stuff, times du over 6 times 1 plus ln x. Okay, now that's convenient because this whole thing is going to cancel out. But let's take a break real quick and find our new limits, because since we've integrated with respect to u and not x, we need new limits. So we have our substitution here. We have that u is equal to 6x ln x. So when u is equal to 1, or I'm sorry, when x is equal to 1, excuse me, when x is equal to 1, we have u is equal to 6 times 1 times ln of 1. Now ln of 1 is 0, so that gives us 0. That's our new lower limit. And then when we say x is equal to 2, which is our upper limit that we started with, we get u is equal to 6 times 2 times ln of 2, which ends up being 12 ln 2. Okay, so I'm going to take this stuff, I can go ahead and write my limit right here. Let's just pretend I wrote that originally. Okay, we cancel out this stuff, and we are left with the integral from 0 to 12 ln 2 of e to the u du. Now that's very easy. That's probably the easiest integral to take, because the antiderivative of e to the u is e to the u. Okay, so we get, this is equal to e to the u, and then 0 to 12 ln 2. Okay, plug that in, and we get e to the 12 ln 2 minus e to the 0. Okay, and that gets us, we can go ahead and bring the 12 back up to the exponent. So that gives us e to the ln of 2 to the 12th power, that's quite a large number, minus 1. Okay, these cancel out. So we get 2 to the 12 minus 1. Now, 2 to the 12, it may even be too big for the calculator to handle. Let's see. It's no, 4096. So 4096 minus 1 equals 4095. And that's the answer to that problem.